What is the reason for difference between integer division and float to int conversion in Python? I have recently noticed that int rounds a float towards 0, while integer division rounds a float towards its floor. For instance, I have read the documentation which specifies class int x, base equals 10. Return an integer object constructed from a number or string x, or return 0 if no arguments are more than given. If x is a number, return x._int_. For floating point numbers, this truncates towards 0. And floor division, mathematical division that rounds down to nearest integer. The floor division operator is //. For example, the expression 11//4 evaluates to 2 in contrast to the 2.75 returned by float true division. Note that -11//4 is -3 because that is -2.75 rounded downward. See PEP 238. But it seems illogical for me that two similar operations, float division to integer, should return different results. Is there any motivation for the differences between the functions?
Consistency. You'll need to follow some very basic and seemingly irrelevant explanations to understand it. In school you have learned division with a remainder, and you have done calculations like this. Later, you have learned divisions for real numbers. Until this point, you might believe that x//4 and int x/4 always give the same result. That's your current understanding of the situation. However, have a look what happens in the integer division. The number behind a cycles from 3, 2, 1 to 0 and then restarts 3, 2, 1, 0. The number in front of the R decreases every fourth step. So, how will it go on? At the same time, the real number division gives us That's why -1//4 gives -1 but int -1/4 gives 0. Is there any motivation for the differences between the functions? Well, they serve different purposes. // is part of an integer calculation with remainders and int gives you the part in front of the dot of a real number operation. You decide what you want to calculate, then you decide which operator to use in Python to get the correct result. Good question. Keep on learning.
I would say that your observation that those two operations should be intuitively similar is expected since on positive numbers they behave identically. But if you look at their origins, one comes from mathematics and the other from computer science, then it makes more sense their different behavior. You can look behind their concepts. Floor division, aka the floor function applied to the math division. Type conversion / typecasting. equals 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 equals. I floor division aka floor function applied to the math division. The floor function is a very well established concept in mathematics. From mathworld.wolfram. The floor function vertical bar underscore x underscore vertical bar, also called the greatest integer function or integer value, Spanier and Oldham 1987, gives the largest integer less than or equal to x. The name and symbol for the floor function were coined by K. Iverson, Graham et al. 1994. So floor division is nothing more than floor function applied to the math division. The behavior is very clear, mathematically precise. Two-type conversion / type casting. From Wikipedia. In computer science, type conversion, type casting, type coercion and type juggling are different ways of changing an expression from one data type to another. In most of the programming languages, the casting form float to integer is applied by rounding rule, so there is a convention. Round towards 0, directed rounding towards 0, also known as truncation. Rounding rule according to IEEE 754. So, in other words, the reason for the difference between integer division and float to int conversion in Python is a mathematical one. Here are some thoughts from Guido van Rossum. I guess I do not have to introduce him. D. From the blog The History of Python, article Why Python's Integer Division Flaws. This disturbs some people, but there is a good mathematical reason. The integer division operation, // and its sibling, the modulo operation, %, go together and satisfy a nice mathematical relationship. All variables are integers. AB equals Q with remainder R. Such that BQ plus R equals A, and 0 less than equals R less than B. Assuming A and B are more than equals 0.
Based on the answer by Thomas Weller, I also found myself a maybe novice explanation for the floor division result from his example of division with a remainder. Seven, 4 equals 1 or 3 equals 1 plus 0, 75 equals 1.75. 3 South African Rand equals 3/4 equals 0.75. -1/4 equals -1 or 3 equals -1 plus 0, 75, or 3, equals -0.25.
If you want to say more, please consider subscribing.